This video goes over lesson 2 notes on page 6 in your unit 6 packet. Excuse me. There's 2 rules for simplifying radicals. 1, no radicand, I guess I better turn my pen on. No radicand can be divisible by a perfect square other than 1. Excuse the handwriting, you'll just have to listen to the words I'm saying because I know that it's not easy to read, but it's also not easy to write on here. So, no radicand can be divisible by a perfect square other than 1. And also no radical in denominator. Okay, so this goes over just simplifying radicals basically that have a denominator. So we took care of the first rule in lesson 1, and now the second rule we're covering in lesson 2. Basically, you can't have a radical in the denominator. So let's look and see what the rule is for getting rid of it, and then I'll show you kind of why that's the rule. So when you have a radical in the denominator, we're going to multiply on top and bottom by that radical. So on top here, we have 2 on the outside, 3 on the inside. We actually can't multiply them, so we just keep them separate. Square root of 3 times square root of 3 is square root of 9, which is 3. So basically by multiplying this radical by itself, it cancels out that square root. Anytime you have a radical, if you multiply it by the same radical, then your answer is just the radicand. So this B looks very similar. The only difference between A and B is that 2 is on the inside in the numerator. So now, since 2 and 3 are both on the inside, we can multiply them together. And then root 3 times root 3 in the denominator is just 3. So always check your radical. Is there anything I can do to simplify square root of 6? Well, it's not a perfect square, and it's not divisible by any perfect squares, so that's as far as we can take it. So it's done. Now C, when you have something that looks like this, we're actually going to split that into 2 parts. We're going to do square root of 2 over square root of 3. So I have to get rid of that square root of 3. I'm going to multiply on top and bottom by it. Root 2 times root 3 is root 6. Root 3 times root 3 is 3. Once again, it's the same answer. Sorry about that. It's the same answer as B. We cannot simplify square root of 6, so we're done. So D, same concept. We're multiplying on top and bottom by square root of 7. Root 3 times root 7 is root 21. Root 7 times root 7 is 7. We cannot simplify the square root of 21, so we leave it. Same thing on E. Multiply on top and bottom by root 7. So 5 times 7 is 35. They're both on the inside, so we can multiply them. Root 7 times root 7 is just 7. So I'm checking, is there any perfect square that 35 is divisible by? And that is no, and so this is as far as we can take it. We look at these numbers on the outside, 3 over 7. We also cannot reduce that, so that's as far as we can go. Let's look at one that we could reduce. So square root of 9 here is 3. 3 over 3 is 1. So instead of multiplying by square root of 9 on top and bottom, since we could go ahead and reduce that or simplify it, we did. What if, and this is not in your packet, I'm just throwing out a what if. What if we had something like, so let's say we have this. So we multiply on top and bottom by root 2. And we get 2 root 12 over 2. So the first thing I notice is that I actually can cancel out these 2's on the outside. And then I also notice that I can reduce root 12 to root 4 times root 3. Root 4 is 2, root 3 gets stuck in. So that's as far as I can take it. Okay, let's look at this next real quick. So example 2, when you have a binomial in the denominator, we're actually going to multiply by its conjugate. Conjugates are just when we multiply, it's the exact same binomial except for that middle sign is opposite. So instead of 3 minus root 2, we're doing 3 plus root 2. We're going to distribute that 2. So 2 times 3 is 6. 2 times root 2 is 2 root 2. And then I'm going to distribute across the bottom. 3 times 3 is 9. 3 times root 2 is 3 root 2. Negative root 2 times 3 is negative 3 root 2. And negative root 2 times root 2 is negative 2. So these things cancel. And I'm left with, on bottom, 7. Now, I cannot reduce the square root of 2. And so I'm looking at 6, 2, and 7. Those are not divisible by anything in common. And so this is our answer. This is as far down as we can reduce it. And you can look on the notes to see how B and C are done.